Hey guys, welcome to Unit 6, Lesson 5. Our topic today is the alternative definition of a derivative. So pause the video, see if you can do the warm-up on your own. So the warm-up says, graph the derivative of a function f whose graph is shown below. Discuss the behavior of f in terms of the signs and values of f prime. So anytime you're given a function and it's asked to graph its derivative, you will be looking for actually the slopes at different points. Slope where it's 0. So slope at C, if you look at C. Oh, my pen's not. Hey guys, welcome to Unit 6, Lesson 5. Our topic today is alternative definition of a derivative. I want you to pause the video and try the warm-up. So the warm-up says, graph the derivative of the function f whose graph is shown below. Discuss the behavior of f in terms of the signs and the values of f prime. I'm going to actually start with the values of f prime. So how do we determine those? The values of f prime are always, you can use the x-coordinate of your original function and the slope at that point. And I did that. So like the first one here, a. What's the x-coordinate here? It's 0 and your slope is 4. So first point would be 0, 4. Then b is 1, 1, 1. X is 2 and your slope is 0. So 2, 0 and so on. And I wrote them up here. So points on f prime will be, these will be the 6 points on f prime. Another thing that you need to pay attention to is, like, if I was to check, like over here, I already wrote the slopes, right? At the peaks, slope is 0. It's constant slope, right? If you've forgotten, let's quickly review this. If you have lines going up or curves going up, slope is positive. Going down, it's negative. Horizontal line, slope is equal to 0. Vertical lines, it's undefined. So this is a quick review of that. So here, I already know from point A to C, I'm going to use a highlighter, that my graph is what? Increasing. If the graph is increasing, those points will be above x-axis. From here, from C to F, this is what? Slope is negative, it's decreasing. So this would be from C to F, those all points will be below the x-axis. Okay, and then here again, from F so on, this is positive, slope is increasing, so this would be above the x-axis. So we're just checking for above and below and where slope is 0. And graph them. So 0, 4, 1, 1, 2, 0, 3, negative 1, 5, negative 1, and what else? 6, 0. Right? So again, look here, from A to C, it was above the x-axis. That's what I say. So look, that point is above, right? At C, your slope was what? 0. So that could be your points. Let's say if you weren't given the points, you know at C, which is at 2 and 6, your graph will hit the x-axis. The derivative will hit the x-axis because your slope is 0. And then from C to F, all those points are below the x-axis, and then it's above. So this is what your graph of the derivative of x is. Okay, so now let's talk about the alternate definition of the derivative. We have been using the difference quotient, and then we expand it, and we do all that algebra. So this kind of helps because this is more has to do with factoring. The other definition has to do with more expanding. You can use either or definition depending on which one would be more feasible. So we can find the derivative of f of x at a point where x equals a by using an alternate definition of the derivative at a point. So basically, the definition is f prime of a is limit as x approaches a, it's going to be f of x minus f of a over x minus a. So I just sketched the graph here. So as x approaches a, do you agree it's going to get very smaller and smaller? This slope becomes the slope of the tangent line at that point rather than between the 2 points. So let's start with the definition and do one question. So let's write down the formula. That is what the alternate definition says. What? Limit as x approaches a, f of x minus f of a over x minus a. Right? So that's your definition, the alternative definition. So it says find derivative of f of 5x cubed plus 1 using the alternate definition. So what I'm going to do is d over dx equals limit. I'm going to just apply that. As x approaches a, what did we say? It's f of x. So f of x is this whole thing. I'll just write that 5x cubed plus 1. And write it in parentheses minus. Now what is f of a? F of a will be basically wherever I see x, I'm going to substitute that with a. So it'll be 5a cubed plus 1. So 5a cubed plus 1. So I'm gonna over x minus a. If I distribute the negative, what do I get? I will get 5x cubed plus 1 minus 5a cubed minus 1. The plus 1 and the minus 1 cancel out. Right? Can I factor out the 5? I can, right? So let's do this here. I'll factor out the 5. I'm left with x cubed minus a cubed. What is x cubed minus a cubed? Isn't that difference of two cubes? So I'm going to write that down here. A cubed minus b cubed, that's what it is. You use the SOAP. A minus b, and then it's a squared plus ab plus b squared. That's what it is. So I'm going to factor this part, and I'm going to write it in terms of this. So this would be 5 parentheses x minus a, and then it would be x squared plus ax plus a squared over x minus a. What happens to your x minus a's? They cancel out, right? So now let's I'm just going to rewrite it here. Limit as x approaches a. So now apply the limit, which would be what? 5. Wherever you see x, you're going to substitute x with what? A. So a squared plus a times a plus a squared, which is what? 5 parentheses 3a squared, which is 15a squared. So that is your derivative using the alternate definition. So what's the difference between the two? I'll quickly sum up. Whenever you use alternate definition, there will be some kind of factoring involved. And if you use the difference quotient, that has to do with expanding. So depending on what you like better, it doesn't really matter. You can use either or. Okay, so let's do this. What is the value of the derivative when a equals 1? So I'm going to do, let's substitute a with negative 1. It's negative 1 squared, which would be just 15. What is the formula for the derivative as a function? So this was what? Y prime is 15x squared. That was your formula for the derivative as a function. So if I'm writing as a function, I actually would use my function notation. F prime of x. Okay, so let's try the next one. It says find the derivative if y equals this using the alternate definition. So I'm going to write y prime equals limit as x approaches a, it is what? F of x, so 2x minus f of a, which would be 2a over x minus a. This is less work in comparison to the other one because you don't have to do all that expanding, so I totally agree. So now how do you solve any kind of question or simplify any question that has radicals in it? We must rationalize. R for radicals and R for rationalizing. Please remember that. Here we're going to rationalize the numerator. Anytime you're multiplying, rationalizing the numerator, you're multiplying and dividing by the conjugate. So it's going to be 2x. Your terms stay the same. The two terms, they stay the same. Only the sign of the second term gets switched. So please remember that. So rad 2x plus, right? So here what do I do? This is, I'm going to use a different color. This is a minus b, and this is what? A plus b. What is a minus b and a plus b? A minus b times a plus b is dots, right? Difference of two squares, a square minus b square. So basically this is my a. I'm going to square this. So this would be what? Just 2x, because the radicals cancel out. I'm going to square this minus. It's minus always. And this would be 2a over, don't do anything to the denominator. 2x, if you want to factor out, doesn't really matter. You can just leave it as that. You really can't factor here. I just don't know why I thought so. But that's what it is, right? So now in the numerator, can you not factor out the 2? So limit, I'm just going to write that here. As x approaches a, 2 parentheses, x minus a over x minus a, 2x plus 2a. These cancel out. What are you left with? Apply the limit. 2 over, wherever you see x, what are you going to substitute with a? So rad 2a plus rad 2a, which would be what? 2 over 2 times rad 2a. What happens to your 2's? They cancel out and you're left with 1. There's 1 in the numerator. Please do not write your final answer as just rad 2a. There's 1 in the numerator over rad 2a, right? So that is your definition or the formula for the derivative. So what is the slope of the curve at x a equals 5? So if I substitute in 5 for a, oh, I went backwards. The 2 is under the radical. So this would be what? 1 over rad 10. Are there any values for a for which the derivative will not exist? So look at your, this formula that you found for the derivative. What value would you substitute it that will make the denominator undefined? That would be 0. So a equals 0. So I want you to finish up the problem set.